Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. In our today's lecture, we will discuss properties of the alkanes. For any organic compound, today we are discussing alkanes, so we will discuss the properties of alkane. For any organic compound, the properties are of two kinds: chemical properties as well as the physical properties. Now let's discuss what are the physical properties. Physical properties are the properties which are determined without the change in the identity of a substance. For example, when these properties are determined, then there is no change in chemical composition of the substance. These properties, melting point, boiling point, color, density, mass, volume, etc., these all are the physical properties. So whenever you determine the boiling point of a substance, then you are not changing the chemical composition of that substance. That substance before and after the determination of boiling point remains the same. So therefore, this boiling point is considered as the physical property. Now, what is the chemical property? Chemical properties are the properties which are determined with the change in the identity of a substance. For example, when you are determining the chemical properties of a substance, then after the determination of that property, that chemical substance will change into another chemical substance. For example, you see when a substance reacts, then after a reaction it got converted into product. Now that product is of different chemical composition as compared to that of the reactant. So this means that during the process of chemical reaction, the chemical identity of the reactant has been changed. So in the chemical properties, always remember that the chemical composition of the substance changes. And in order to study the chemical properties, we study that how does a substance reacts to air, acid, water, base and other chemicals. So in today's lecture, we will discuss these properties of alkanes. So let's first discuss the physical properties of alkanes. First property of the alkane is that they are non-polar. Why non-polar? We know that since alkanes are hydrocarbons, so they contains only carbon and hydrogen. The electronegativity difference between these two elements is very low. And because of low electronegativity difference, the bonds of carbon and hydrogen are not polar. So therefore, these hydrocarbons are generally considered as the non-polar chemical substances. Always remember that these alkanes are less dense than water. Now let's suppose that you have two substances, N-hexane and water, in a beaker. And we have to mix these two substances in a beaker. Always remember that when these two substances are present in a beaker, then the water will be present below the N-hexane because the density of N-hexane is smaller than that of the water. These alkanes are insoluble in water. Why insoluble? We have read about the solubility principle, that is like dissolves like. So water is slightly polar, means that the bonds, that is OH bond in water is polar because of the electronegativity difference between oxygen and hydrogen. Now we have read before that these alkanes are non-polar. Water is slightly polar compound. So since the alkanes are non-polar, therefore they are insoluble in polar substances like the water. So now we will study about the physical states of the alkanes. Alkanes having carbon number 1 to carbon number 4 are colorless, odorless gases. Odorless mean that they have no fragrance, or you may say no smell. By C1 to C4 I mean alkanes that are methane, ethane, propane, butane. These alkanes are colorless, odorless gases. Now, the alkanes with C5 to C17 are colorless, odorless liquids. This means that the alkanes containing carbon number 5, 6, 7 up to carbon number 17 are liquids, and they are colorless as well as have no smell. Higher alkanes, the alkanes having carbon number greater than 17 are colorless, odorless solids. So if you look at this pattern, you will see that with the increase in the number of carbon atoms in an alkane, the physical state of the alkane changes from gases to liquids and from liquids to the solids. So all the higher alkanes having carbon number greater than C17 are solids. Now another property that I will share here with this pattern is that as the number of carbon atom increases, boiling point also increases. This means that the lower alkanes like C1 to C4 or C5 to C17 have low boiling point as compared to the higher alkanes. Now since lower alkanes have low boiling point, this means that lower alkanes are more volatile. So these were the physical properties of alkanes. Now we will move towards the chemical properties of alkane. First property is that alkanes are unreactive towards ionic compounds. We have discussed before that since alkanes are non-polar, so therefore they will not react with any other compound having poles in it. Now these ionic compounds contains positive and negative charges. Therefore alkanes will not react with these ionic compounds. And because of this lack of reactivity, these alkanes are used as solvents. What are solvents? Solvent is a chemical substance in which a solute is dissolved, and solvent is present in a larger amount as compared to the solute. For example, hexane, which is an alkane, is used to extract vegetable oil from corn, soybean and cottonseed. Now these are the sources of vegetable oil, and why hexane is used to extract this vegetable oil? Because hexane do not react with this vegetable oil. Now we will discuss two important chemical reactions of alkanes in today's lecture. First one is the halogenation. What is halogenation? Halogenation is the replacement of one or more hydrogen atoms in alkane by the halogens. Now, since the halogens are replacing the hydrogen atom in this reaction, therefore, it is also called as the substitution reaction. The process of halogenation occurs in the presence of the sunlight. In the process of halogenation, or in the chemical reaction of halogenation, the reactants are alkane and the products are alkyl halide or maybe carbon and HCl. This is an example of a chemical reaction related to halogenation. We have methane. When this methane reacts with the molecule of bromine, then one of the hydrogen atom in the methane gets replaced by the bromine atom. Now here, since the bromine atom is replacing hydrogen atom in an alkane, therefore this reaction is called as the halogenation. It may also be called as bromination. Now, halogenation may occur in diffuse sunlight as well as in direct sunlight. So what is diffuse sunlight? In this figure, you may see that on this glass, the sun rays are directly hitting this glass, directly incident upon this glass. Now, since the sunlight is directly hitting the glass, so there is the higher intensity of sun rays. This is called as direct sunlight. Now, if you look at the plants, then here the sunlight is not direct because some of the sunlight has been scattered by this glass. This diffuse glass has scattered some of the rays of the sun. Now, after scattering, the sunlight becomes less intense. So, therefore, it is called as the diffuse light. So, in the diffuse sunlight, the end product of the halogenation is the halogenated alkanes, that is haloalkanes. We have an example of methane. Now, in the halogenation process, if enough supply of the halogens is there, then all the hydrogen atoms in a chemical compound gets replaced by the halogen atom. For example, in methane we have 4 hydrogen atoms. So all of these 4 hydrogen atoms will be replaced by the halogen, that is the chlorine here. So this is a step-by-step process. In the first step, methane reacts with chlorine in the presence of diffuse sunlight to form chloromethane and HCl. In the second step, now this chloromethane still contains 3 hydrogen atoms. So this means that there is the possibility of further replacement of these hydrogen atoms. So in the second step, chloromethane reacts with chlorine to form dichloromethane and HCl. Now this reaction can also occur further because it contains 2 hydrogen atoms. So this dichloromethane will again react with chlorine to form trichloromethane, which is also called as the chloroform. Now since this chloroform still contains 1 hydrogen atom, so it can then further react with the chlorine again to form tetrachloromethane, that is also called as carbon tetrachloride. Now after the formation of carbon tetrachloride, this reaction will stop because now this carbon tetrachloride does not contain any more replaceable hydrogen atoms. So if you have enough supply of halogens, that the end product of the reactant do not contain any replaceable hydrogen atom. However, in the reaction mixture, you may find all of these substances. There may be chloromethane, dichloromethane, trichloromethane, and tetrachloromethane. All four substances will be present in a reaction mixture. Now we will discuss the halogenation in the direct sunlight. First we discussed the halogenation in the diffuse sunlight. Now we are discussing the halogenation in the direct sunlight. In the direct sunlight, the end product is the carbon and HCl. For example, if methane reacts with chlorine in the direct sunlight, then it will result in the formation of carbon as well as 4 molecules of HCl. In the halogenation, all the halogens do not react same. The order of reactivity of halogens in the halogenation is like this. We have fluorine, chlorine, bromine, and iodine. Now, fluorine reacts explosively. This means that fluorine is the most reactive halogen out of all other halogens. Chlorine reacts slowly in the dark room at the room temperature. However, if the sunlight is provided, then it reacts rapidly with the alkanes. For bromine, they are less reactive than chlorine or fluorine, and they require strong sunlight and higher temperature in order to react with alkanes. Iodine is the least reactive of all the other halogens. So this is the order of reactivity of halogens. Fluorine more reactive than chlorine, chlorine more reactive than bromine, and bromine is more reactive than iodine. So out of all these halogens, fluorine is the most reactive and iodine is the least reactive. Now let's discuss another chemical property of this alkane, that is the combustion. What is combustion? A reaction of substance with an oxygen or air that causes the rapid release of heat and appearance of flame. So what happens in combustion? That substance is burned in the presence of oxygen, which results in the release of heat and the appearance of flame. So this means that process of combustion is usually carried out in order to get the heat energy. Combustion is of two types: complete combustion and the incomplete combustion. And always remember that alkane burns with the blue flame. Now we know that natural gas is the domestic fuel that we usually employ during the cooking process. Now this natural gas is mainly methane and also contains some amount of ethane, propane, and butane. Now what are these substances? These are alkane. If you look at the flame of these chemical substances when they are burned, then it is blue in color. Oil, petrol, and diesel are all examples of hydrocarbons. What is a hydrocarbon? A hydrocarbon is a compound made of carbon and hydrogen. Burning hydrocarbons will produce water, carbon dioxide, and energy. So these are the products of the combustion. What we get at the end of combustion? We get water, carbon dioxide as well as the heat energy. For example, we have methane. When methane is burned in the presence of oxygen, it results in the formation of carbon dioxide as well as the water molecule. Now, since methane is a hydrocarbon, so it contains two elements, carbon and hydrogen. So during the process of combustion, carbon gets converted into carbon dioxide and hydrogen gets converted into water. This process of combustion is also called as oxidation reaction because here the carbon as well as hydrogen are being oxidized. Oxygen atoms are being added to carbon as well as the hydrogen atom. In this reaction, the hydrocarbon is oxidized. Oxidized means that oxygen has been added. Now, we have read before that combustion is of two kinds, complete combustion and incomplete combustion. So, what is a complete combustion? Complete combustion is a combustion that occurs in the presence of excess supply of oxygen. In the complete combustion, the end product is the carbon dioxide and water plus energy. For example, we have methane. Now, this methane reacts with oxygen to form carbon dioxide and water. So, look at the end product here. Then these end products are the carbon dioxide and water. Now, let's balance the chemical equation. The carbon atom on this side of the equation is 1. And here it is also 1, so this means that carbon atoms are balanced. We have to balance the hydrogen atoms on both sides. At this side, number of hydrogen atom is 4. On this side, the number of hydrogen atom is 2, so we need to put coefficient 2 before water molecule. Now we are left with oxygen atom. If you look at this side of the equation, the number of oxygen atom is 2. If you look at this side of the equation, the number of oxygen atom is 2 plus 2, that is 4. So in order to equalize the number of oxygen atoms on both sides of the equation, we will put the coefficient 2 before oxygen. So now you may see that the chemical equation has been balanced. So this is an example of the complete combustion because at the end you got carbon dioxide, water and energy. Now what is an incomplete combustion? Incomplete combustion occurs in the presence of a limited supply of oxygen. Complete combustion occurs in the presence of excess supply of oxygen. Incomplete combustion occurs in the presence of limited supply of oxygen. The end product in the incomplete combustion is the carbon monoxide, carbon and water. What were the end products in complete combustion? In the complete combustion, end products were carbon dioxide and water. In the incomplete combustion, the end products are carbon monoxide, carbon and water. So this is an example of incomplete combustion when methane reacts with limited supply of oxygen, then it results in the formation of 2 moles of carbon monoxide, carbon and the water molecule. So we have read before that as in the natural gas, since natural gas contain a lighter alkanes or a diesel also contain lighter alkanes. By lighter alkanes, I mean the alkanes having fewer number of carbon atoms. So these lighter alkanes are mainly employed in the fuels. Why? First reason is that their combustion can be controlled. Second reason is that they produce large amount of heat per gram. And the third reason is that they are cheap and they are readily available. And because of these 3 reasons, these lighter alkanes are used as the fuels. So let's revise the combustion reaction. It's of two kinds: complete combustion, incomplete combustion. Complete combustion occurs in the excess supply of oxygen, and the end product of the complete combustion is carbon dioxide and water. Incomplete combustion occurs in the limited supply of oxygen, and the end products are the carbon, carbon monoxide and water. So let's watch a short video on the combustion reaction.
We saw in the last video that alkanes are a homologous series of hydrocarbons that contain only carbons and hydrogen atoms with no double bonds. And we covered the names of the first 4 alkanes in the series. In this video though, we're going to talk about the properties of alkanes and then see how we can write equations for their combustion. Although all alkanes have similar properties, there are trends that you need to know about as the length of the carbon chain increases. The first is that the boiling point increases with chain length. So these 4 here all have fairly low boiling points and so exist as gases at room temperature because they have the shortest chains. However, longer alkanes with more than 4 carbons are liquids at room temperature. And if the chains are really long, then they could be solid. This feature actually explains their next property as well, which is that shorter alkanes are more volatile, meaning that they evaporate more easily because of that low boiling point we just talked about. Meanwhile, the longer alkanes are more viscous, which just means that they're kind of thick and sticky, like honey. The last property you need to know is that shorter alkanes are also more flammable, which means that they're easier to ignite or burn, as we'll see when we come to crude oil. The next thing we need to look at is combustion reactions. One of the main uses of hydrocarbons, like alkanes, is for fuel, because they release loads of energy when they're burned with oxygen. As long as there's enough oxygen available, we get complete combustion, which is when a hydrocarbon reacts with oxygen to form carbon dioxide and water, releasing loads of energy in the process. So we could say that it's an exothermic reaction. We could also say that the hydrogen and carbon in the hydrocarbon are being oxidized, as each of the elements is combining with oxygen to form CO2 and H2O respectively. Now, when it comes to exams, you need to be able to write out the equations and balance them. For example, you could be asked to write the balanced equation for the complete combustion of propane. We saw earlier that propane is C3H8. So we'll react this with O2 to form CO2 and H2O. Then all we need to do is balance it. We know that on the left we have 3 carbons, so on the right we'll need 3 CO2s. We also have 8 hydrogens on the left, so because each H2O molecule contains 2 hydrogens, we know we'll need 4 of them on the right. Then lastly, we need to balance the oxygens. On the right, we now have 6 oxygens in the CO2s, plus 4 oxygens from the waters, so 10 in total. So to get 10 on the left, we'll need 5 oxygen molecules. And finally, we just need to double check that all the numbers balance, which they do, so we're done.
Now let's do certain exercise questions related to the previous topics and the topic that we have read today. First, starting with the MCQs. Which molecule contains a carbon-carbon double bond? Now you are given 4 options. First one is the ethane. Now ethane, you know, is an alkane, and in alkanes all the carbon-carbon bonds are single. So this is not a right option. In ethyl alcohol, you know that you have a COH bond, and all the rest of the bonds that are carbon-carbon as well as the carbon-hydrogen bonds are single. This is the structure for ethyl alcohol. Now ethyl alcohol, all the you have a single carbon-carbon bond, and that single carbon-carbon bond is not double, as you may see in the structure. So this is not a right option as well. If you look at ethine, then since it is an alkyne, so it contains a triple bond between two carbon atoms. So this is also not a right option. We are left with ethene. In ethene, we have double bond between two carbon atoms. So the right option for this MCQ is the ethene. Now, which product is obtained when chloromethane is reduced? Now, by reduction of chloromethane, this means that here the hydrogen atom is being added. We have CH3Cl. Now, what will happen that when hydrogen atom will be added to this carbon atom, so before addition it would replace this chlorine atom. Now after the replacement of the chlorine atom, this CH3Cl will be converted into CH4, that is methane. So this means that methane will be obtained when the chloromethane will be reduced. Which reacts explosively with methane? We have read about it in the order of reactivity of halogens, that fluorine is the most reactive out of all the other halogens. So it reacts explosively with the methane. The reduction of alkyl halides takes place in the presence of, we have read about it before, that during the reduction of alkyl halides we need nascent hydrogen. Now in these nascent hydrogens are produced when zinc reacts with hydrochloric acid. So the right option for this MCQ is Zn plus HCl. So here are some short questions. First one is, give 3 examples of unsaturated hydrocarbons. We have discussed about unsaturated hydrocarbons and again. So you may give the example of alkenes, or you may give the examples of alkynes, because both the alkenes and alkynes are the unsaturated hydrocarbons. You may give example of benzene. There are many examples. I will be giving 3. That is the benzene. This benzene is also an unsaturated hydrocarbon. You may give the example of ethine. It is an alkyne. You may give the example of ethene. It is an alkene. Now the second question is, draw electron and dot structure for ethene. We have discussed about it earlier as well. In ethene we have a double bond. So how a double bond is formed? It is formed by sharing of 2 pairs of electron between same atoms. Alright. So let's discuss that we have, in ethane we have 2 carbon atoms. Now if these 2 carbon atoms are having double bonds, so this means that these 2 carbon atoms are sharing 2 pairs of electron. First pair, second pair. Now this carbon atom is left with 2 unpaired electron. Similarly, this carbon atom is left with 2 unpaired electrons. Now these two unpaired electrons will be shared with respective hydrogen atoms in order to complete its octet. So this is how the electron dot and cross structure for ethene will be drawn. Third question is draw structural formula of an alkane, alkene and alkyne containing 5 carbon atoms. So for alkanes, you know the general formula is RH. So what you will do, you have to draw 5 carbon atoms in a row and then you will write hydrogen atom with each carbon atom. So the alkane with the 5 carbon atom is the propane. Similarly, the general formula for alkyne is you will write it like this, alkene, sorry, not an alkyne, alkene. So what you will do, draw 5 carbon atoms in a row. Now since here position of double bond is not mentioned, so you may draw double bond anywhere and then write the hydrogen atoms along with each carbon atoms. So this is an example of 1 pentene. Similarly, you will also draw the structure of an alkyne like 1 pentyne. Here, what you have to do, you have just to draw a triple bond and the name becomes 1 pentyne. So here is a short activity. You have to differentiate ethane from ethene. Now how will you differentiate it? Do it on your own and write it on the in the comment box below. Thanks. And if you have any question, then you may contact me at my Gmail ID, or you may also write your queries or questions in the comment box below. So this was all for today. Thank you for being with me.